let's figure out the derivative for secant x. Well, first we have to know that secant is the same as 1 over cosine. So let's go ahead and write that down as to take the derivative of 1 over cosine x. Because once we have this, we can use the quotient rule. This is the bottom function, so I'll write that as g, which is cosine x, and then the top function is just 1. And now let's go ahead and do the derivative. The derivative of cosine is negative sine, and of course the input is x. And then the derivative of 1 is just 0. And now we are good to go. So here we go. Big fraction bar, this is the bottom, right? Cosine x, and then we have to square that. So let's put a parentheses right here and square that. And now for the top, we have this times that, which is cosine x times 0. So let me just write that down here. And then next, we minus this times that. So we have 1 times negative sine x. Alright? So now that's what we have. Okay. We see that this times that is just 0, so that's good. And another thing to pay attention is, so negative times negative, we get positive, and we have just sine x right here. Yeah. And then over, here we have cosine x squared, which means we have cosine x times cosine x. So let me just write them out separately, because this is what we are going to do. Right here, I can purposely put down 1, right? 1 times sine x, which is the same as sine x. And the reason I want to do that is because when we have 1 over this, so I'm just going to color this to make it red, because 1 over cosine x is just the same as secant x. So I'm going to write that part as secant x. And then when we have this over that, well, sine x over cosine x is just tangent x, and of course they are still multiplying. So that's it. And in fact, when we take the derivative of secant x, you see that the secant x part repeats, and we just pair this up with tangent x, which is kind of similar when we take the derivative of cosecant x. Alright? So that's it for this one. If you need to see other derivatives, so check out my other video for that.